Hey mathematicians, it's our last homework before vacation. Let's do it. Let's get it over with. Okay, the first problem, we are making a dot plot. So you can already see one dot right here, this 7. So 7's off. You're going to make a dot for each of these other numbers, create your dot plot, and then answer these two questions. Range is the biggest dot minus the smallest dot. Median is the middle dot when ordered from least to greatest. So you can literally cross off the smallest dot, the biggest dot, the smallest dot, the biggest dot, and find your middle dot. Next up is a histogram. This is where we've spent the least number of practice hours, so let's do this one together. What I expect to see is frequency. The number, how often do you see a number in the 1950s? So what I'm going to do is, since they all start with 19, I'm just going to write the last two digits. So 82 goes in the 80s. 91 is in the 90s. 94, that's the year I was born. 90s. 89 goes in the 80s. 74. So you're going to fill in your whole table here with all of the years that these teachers were born. '85, '87, '93, '78, '81, '82, '70, and '90. Then we're going to tally up the frequency. So we have one person who was born in the 50s, 2 people born in the 60s, 4 in the 70s, 2, 4, 6 in the 80s, and 5 in the 90s. So a histogram is made of rectangles that touch because you are going to represent that people exist exactly between the 50s and the 60s. There's no gap between them. There's not like a break year. People still keep having birthdays. So the 1950s is a frequency of 1, so your rectangle should be 1 unit tall. 1960s is 2, your rectangle should be 2 units tall. Finish your histogram according to this frequency table over here. The most often occurring, that's the mode. Which decade is the mode? True or false, teachers in the school have an age range. Range means biggest minus smallest. So find the oldest teacher, and I would be the youngest teacher in this data set, and subtract them. If the answer is 40, great, it's true. If the answer is any number other than 40, it is false. Next page. You are creating a box and whiskers plot. So you got your numbers. You need to put them in order from least to greatest. 23, 25, that's a terrible 5, 26, and 30. You're going to find your second quartile first. So the number in the middle, not this one, 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 not this one. Eep! What's in the middle of 18 and 23? I don't know. So I'm going to go off to the side and write 18, 19, 20, 21, 22, 23, and keep crossing things off. Not this one, not that one, not this one, not that one. What's in the middle of 20 and 21? 20 and a half. 20 and a half. All right, so then you go and you find your quartile 1, the number in the middle of the lower set of data. In the middle of 10 and 13, I don't know, 10, 11, 12, 13, not this one, not that one. Oh, what's in the middle there? 11 and a half. And your third quartile, not this one, not that one. In the middle of 25 and 26 is 25 and a half. Range is the maximum, 30, minus the minimum, 8. That gives you a range of 26. No, that is not true. Don't listen to me. My brain is already on vacation. That gives you a range of 22. Oh, Miss Douglas, what are you doing? So now you're going to make, on this graph that I wish was a little bit further down, a box and whisker plot. You need 5 numbers. Those 5 numbers are your minimum. Quartile 1, quartile 2, quartile 3, and your maximum. So minimum is 8. Quartile 1 is 11.5. Okay, so this goes from 10 to 12. Let me zoom in for you. 10 to 12, which means that 11 would be right here. So if you're looking for 11.5, you want to be closer to the 12 than the 10, but not right in the middle. Then we also need 20.5, same deal. This line is 21, so 20.5 is going to be closer to 20. 25.5, here's 25, so 25.5 is going to be closer to 26. And the maximum is 30. A box and whisker plot has 2 whiskers on either side. And it has a box that is separated by the median, so it kind of looks like 2 boxes together. Ta-da! Stem and leaf plot and a key. Your stem is your tens place. Really, it could also be, if there was like a number that had 3 digits, your tens and your hundreds. It is everything except for the ones place. So I can see here that I have 10s, 20s, and 30s. 10s, 20s, and 30s. So you need to fill in your leaves in order from least to greatest. You also need a key, which can be any example from this problem. So for example, 12. 12 is my smallest leaf right there, my minimum, and I could say 1, 2 equals 12. And that's your first leaf. There you go. Last problem. No, that's not true. Second to last problem. Here's your data set. You need to find the mean, add them all up, and divide by 1, 2, 3, 4, 5, 6. Tell me what that is. You need to find the median, put them in order of least to greatest, and find the middle number. You need to find the mode, the most common number. It's possible to have no mode, in which case you would literally write the words no mode. It's possible to have one mode, just write the number that's the most frequent. 2 modes, if they're tied, write them both. 3 modes, if they're tied, write them both. And last step, range. The biggest number minus the smallest number. Tell me what that answer is. Last one. Oh, this one is interesting. All right, so we have a box and whisker plot, but something's wrong. This person, Jim, forgot one part of the box and whisker plot. Is it the upper extreme? What does that mean? Upper would be like bigger, right? The bigger extreme. If I tell you you are extremely loud, that means you are the loudest. So if I'm looking for the uppermost, the biggest, that would be the maximum. If I tell you you're extremely quiet, that means you are the quietest, also known as the smallest voice, the minimum. If I'm looking at my upper quartile, I'm looking at the biggest quartile, which would be quartile 3. Or median, you know, means the middle number. So which of those is missing from this graph? Circle it and celebrate because you are done with homework until after spring break. Don't forget to bring it back though.